We are on lesson 6.3, using ratios and rates to solve problems. The essential question is, how can you use ratios and rates to make comparisons and predictions? And we start off with an explore activity. And on the explore activity, I will read the directions with you, but then I'd like you to try as much of the page as you can. When you're done, or when you get stuck, you can then resume the videos for hints and or to check your answers. So read the directions with me and then hit pause and try questions A through E. Anna's recipe for lemonade calls for 2 cups of lemonade concentrate and 3 cups of water. Bailey's recipe calls for 3 cups of lemonade concentrate and 5 cups of water. Question A is about Anna's recipe. In Anna's recipe, the ratio of concentrate to water is blank. And then it says use equivalent ratios to complete the table. I have a feeling you could reread the directions and easily find Anna's recipe and record her ratio, and then you could easily fill in this table. So again, pause the video and then resume it when you're ready to check your answers. Okay, so I'm going to move this up. We can now see all of Anna's table, all of Bailey's table, and we can see the directions. So the first one is about Anna's recipe, and Anna's recipe is, if you go back and find the directions, it is 2 cups of lemonade concentrate to 3 cups of water. And so the first question says write the ratio. You could write it as 2 to 3, or you could write it as a fraction where we write it as 2 over 3. And the only reason why a fraction works better is because if you kind of imagine that in the form of a table, that actually exists right here. So notice that the first terms, or the next column over, are the original recipe just multiplied by 2. 2 times 2 is 4, and 3 times 2 is 6. So that's the missing number. And notice on the third column over, it's tripled. So 3 times 3 is 9, and we have to do the same thing to the first term. 2 times 3 is 6. And you might make a mistake here if you just think there's a pattern. If you think that the fourth column must be everything times 4, notice that on the second term they didn't do times 4, they did times 5. So you have to do times 5 on the first term as well, which is 10. They kind of just skipped right over the fourth term, and the textbook doesn't have an obligation to give you a perfect pattern. So let's check out Bailey's recipe. Let's go back up to the directions. I think I'll switch color for Bailey. We'll make his green. Bailey's recipe calls for 3 cups of lemonade and 5 cups of water, which is again found in your informational table, 3 to 5. And so I'm going to write on the line, in Bailey's recipe, the ratio of concentrate to water is 3 to 5. Or you could write it as a ratio with a colon, that's fine too. And again, I'm sure you wouldn't have made this mistake again, but notice that they started off the first column over, they tripled that original recipe. So 3 times 3 is 9, which means I have to do 5 times 3 is 15. And the next column over is to take the original numbers, 3 and 5, and multiply them by 4. So this missing number would be 20. And the third term over, they don't give you any information. And so here's what you're looking at. If you're stuck on this, here's what you're looking at. The original recipe was 5 cups of water, and we have increased it to 25 cups of water. And they kind of give you a hint. How do you get from 5 to 25? Well, you multiply by 5. And this times 5 right here is what we have to do to the top as well. If you multiply the amount of water in a recipe by 5, you have to multiply the concentrate by 5 as well. So this missing number would be 15. Okay, so I'm going to need this information later as we move down the page. So I'm going to take a quick snapshot of it, and I'm going to bring it down the page with me. Oh, there it is right there. I think I can probably shrink that now, which I'm going to need to do. Well, we'll figure it out. I'm going to go ahead and move the page up. And we're on question C now. And question C reads, find 2 columns, one in each table, in which the amount of water is the same, and circle these 2 columns. And I guess I can bring my table back right here. Maybe I can do this. If I shrink it just a little bit, I should be able to find those columns. It says find 2 columns, one in each table, in which the amount of water is the same. So water is the second term, so I'm going to look here for the water. And the water in Anna's table goes 3, 6, 9, 15. And the water in Bailey's table goes 5, 15, 20, 25. And the only number I said twice there is 15. So I'm going to switch colors. And what I noticed here was that in this column, 15 is the second term, and in this column, 15 is the second term, which is 15 waters, which means that in those two, I guess it says circle. I didn't circle, but I can. There, circle those. So I've answered question C. It means that Anna's amount of water is 15 cups, and Bailey's amount of water is 15 cups. And so that helps us with question D, which reads, whose recipe makes stronger lemonade, and how do you know? Well, since both recipes have 15 cups of water, the stronger lemonade would be the one with the more concentrate. And so if Anna's, I'll point to the table up here, if Anna's has 10 cups of concentrate for 15 waters, and if Bailey's has 9 cups of concentrate for 15 waters, well, 10 is slightly more than 9. So who makes a stronger lemonade? It's Anna. Because for 15 cups of water, she has more cups of concentrate. It's close, but it's more. And the very bottom, question E, is kind of the same thing. It says compare the ratios. 10/15. This is kind of a summary. 10/15 is greater than 9/15. And off to the right, what they're doing is they're comparing their original recipes. The one on the left is Anna's. Her original recipe was 2 to 3. And the one on the right is Bailey's. His original recipe was 3 to 5. Well, same thing. These are the same terms as the one we just did, but they're simplified. 2/3 is slightly greater than 3/5.